Hi, my name is Jonathan and I will try to give you a little tutorial about significant figures. In chemistry or physics, we use some measuring devices to take measurements. The problem is with every measurement, there's always a certain level of uncertainty. And because of that, they came up with what we call significant figures. And the number of significant figures is simply the number of figures or digit that we actually know with a certain degree of certainty or reliability. And they have some rules for determining the number of significant figures in a result. The number one rule tells us that all non-zero digits are significant. So if I have a result like 1,235 grams, so since the rule tells me that all non-zero digits are significant, since 1 is non-zero, 2, 3, and 5 all are non-zero digits, so I have 4 significant figures. So I would just say, okay, this is straightforward, 4 significant figures. So the second rule tells us that the zeros between non-zero digits are significant. So zeros between non-zero digits are significant. If I have a measurement like 1,055 kilograms, so I know that the non-zero digits are significant, so I know that 1, 5, and 5 are significant. So that should be 3 significant figures. But since the second rule tells me that the zeros between 2 non-zero digits are also significant, that tells me that I'm going to have 4 significant figures. And the third rule tells me that the leading zeros to the left of the first non-zero digits are not significant. So if I have a leading zero in a measurement like 0.157 grams, since I know that the leading zeros to the left of the first non-zero digit are not significant, I know that zero is not significant and the non-zero digits are significant. So that tells me that I have 3 significant figures. And the last rule tells me that trailing zeros are significant only when they are to the right of a decimal point in a number. So trailing zeros, if I have a measurement which is 1.500 gram, so I have 1, 2, 3, and 4 significant zeros, 4 significant figures, because the 2 trailing zeros are to the right of that decimal point and they are significant also. So that's 4 significant figures. So we also have a set number of rules for adding and subtracting measurement. So when we are adding and subtracting measurements, we also have to look at the number of significant figures. The rule says that when we are adding measurements, our answer has to have the least number of decimal places. So let's say, for example, I'm adding 100, which has 3 significant figures, right? Plus 24.1, which also has 3 significant figures. So my answer should just be 124.1. But the rule tells me that I have to look at the number that has the least number of decimal places. So let's look at 100. 100 has 0 decimal place. And let's look at 24.1. 24.1 has only one decimal place because 1 is the only one decimal place, right? So we're just looking at the number after the decimal. 100 has nothing after the decimal, and 24.1 has only one number after the decimal. So my answer needs to be rounded off with just no decimal places. So my answer should just be 124, which has no decimal places. So this is the rule for adding or subtracting numbers. Now, let's look at the rule for multiplying or dividing numbers. So when we are multiplying, the rule tells us that we have to look at the number with the least number of significant figures. So, for example, if I have 4.0 and I'm multiplying it by 12.00, so first thing we do before we multiply, we look at which one of those numbers has the least number of significant figures. So 4.0 has 2 significant figures, and 12.00 has 1, 2, 3, 4 significant figures. So that tells me off the bat that my answer has to have 2 significant figures because I have to choose the number with the least number of significant figures. So my answer is 48, which has also 2 significant figures.